we are discussing about the satellite. Satellite is the heavenly body revolving around the earth in the particular orbit. So we can define it as the heavenly body revolving around the earth in the particular orbit is called satellite. And there are two types of satellite in nature. The first one is natural satellite and another one is artificial satellite. Now let's talk about the natural satellite. Natural satellite is the satellite which is found by naturally is called the natural satellite. For example, moon. The example of moon we have seen in picture 1. The natural satellite is moon for our earth, okay? And the another one is artificial satellite. The satellite which is made by the human beings is called artificial satellite. For example, geostationary satellite, okay? And it is shown in figure 2. Figure 2 is the artificial satellite, and the artificial satellite is made by human beings. Now let's talk about the orbital velocity of satellite. Here in the figure, the orbital velocity is defined as the velocity at which a body revolves around the planet in a fixed orbit. And let us consider the earth is spherical in shape, having radius capital R, and the satellite is at height h from the surface of the earth, so that the total height from the center of the earth is r plus h, and the satellite orbiting around the earth with the orbital velocity v0 vo. And now the force of attraction between the satellite and earth can be calculated as F is equals to gmm by r plus h whole square, equation first. Similarly, the centripetal force can be written as F equals to mv square by r plus h, and from this equation 1 and 2 we can write gmm by r plus h whole square is equals to mp naught square by r plus h. Now here, after solving, we will get the equation v naught is equals to root under gm by r plus h, and this is the required expression for the orbital velocity of the satellite. But as we know that g equals to gm by r square, so in place of gm we can put gr square. So equation third becomes v naught is equals to root under gr square divided by r plus h. Here also the r square we have to take outside the root, so the required expression is v naught is equals to r root under g divided by r plus h, and this equation 5 is the required expression for the orbital velocity of the satellite, okay? In this way we can calculate the orbital velocity of satellite. Now let's talk about the time period of the satellite. Time period of satellite is the time taken by satellite to complete one revolution around the earth, and it is calculated as time period is equals to circumference of the orbit divided by orbital velocity. So the circumference of the orbit is 2 pi r plus h and divided by orbital velocity, so we get equation first. Now since the orbital velocity is equals to root under gm by r plus h, by substituting this value in equation 1, then we will get the time period of the satellite, and the time period of the satellite can be written as t equals to 2 pi by r root under r plus h whole cube divided by g, and this is the required expression for time period of the satellite. In this way we can calculate the time period of satellite also. Now let's talk about the height of the satellite from the earth's surface. Here in the figure is the height of the satellite. Now to calculate this height of satellite we have to start from the time period of the satellite. As we know that the time period of the satellite is equals to 2 pi by r root under r plus h whole cube by g. So squaring both sides, we have t square equals to 4 pi square r plus h whole cube divided by r square by g. And after solving these all equations we get the required expression for height h equals to t square r square g divided by pi r square 1 by 3 minus r, and this equation is the required expression for height of the satellite. In this way we can calculate the height of the satellite also. Okay,